learn, we're going to have to apply it to our daily life questions. So we are going to look at these examples. So a grid has been superimposed on the gateway arc in St. Louis. Find the equation that models the arc. So here's your question. Here's your picture. Right? They have the axis, the x and the y-axis. So it has been superimposed on the arc of St. Louis. And they're asking you to find an equation that models the arc. What does that mean, find an equation that models the arc? Yeah, it's a quadratic shape. We know the vertex form, so we're going to have to start with the vertex form.
And we have the vertex from just and the
Perfect. So remember, if it's asking you to find an equation, it's asking you to find the an equation. For now, it's the only equation that we know is the vertex form, right? And we can use the vertex form because I know my vertex, right? So what is the vertex in this graph? It's on the origin, so 0, 0, right? Because this is, if you, I don't know if you guys can see this, but this here is your x-axis, and this here is your y-axis, okay? So this is how they place it. This is how they superimpose it. Okay, and this is your arc. So all right, so I know that my vertex is 0, 0, and I know another point, right? I know two other points. I need to use one of them. So I'm going to pick this point here, which is 3 and negative 4. I don't know if you guys can see this, but the point that they've given me here is 3, negative 4. The point that they've given me here is negative 3, negative 4. So I can pick either point. So the first thing you're going to do is you're going to sub the h and k, because you know your vertex, right? So you're going to sub in 0, 0 for h and k.
It doesn't matter which point I choose, right? Then it would give me the same result.
For which one?
I mean, both of them.
Yeah,
Because
for
the same.
both of them it's going to give you the same, but for the h and k there's only one h and k.
Yeah, sure.
Yeah. But now to pick x and y, you can pick any of the points. Okay? So I'm going to pick this one. Doesn't matter, honestly. So I'm just going to pick this one, x and y. So the y is negative 4, and the x is 3. So as I did yesterday, as we did yesterday, to solve for a, you need to simplify, and then you need to isolate. Okay, so that's negative 4 equals to a times 3 squared. Do I need to keep that plus 0? No, it's not going to make a difference. Right, plus 0, it's not going to add or subtract anything. So negative 4 equals to 9a. And then to isolate for a, you just have to divide by 9. And then my a is negative 4 over 9. Okay. I'm just going to leave it as is, as a fraction, and I'm going to plug it in. So y equals negative 4 over 9. What's x minus 0 squared? X squared, that's it, right? So I have x minus 0 squared, so that's x squared, and then plus 0. I don't have to include that. Right? So my equation is going to be as negative 4 over 9 x squared. Okay? Does it make sense? Your a is negative? Yes, it's reflected in the x-axis. Does it make sense that I don't have any horizontal or vertical translation? Right? Because the vertex is at 0, 0, I have no horizontal or vertical translation. The only thing I have is a reflection and a vertical compression. No, you don't. You can write it like this. Are we okay with this? All right.
Not necessary to add, put this here in the bracket, right?
Mhm.
Necessary to add the H.
Yeah.
and-
So because you have
Yeah, 0, 0.
x minus 0, right? So you don't need x minus 0 is just x. So a football was kicked. Its path can be modeled by the relation h is equal to negative 0.1 d minus 8.7 squared plus 7.6, where h is the football's height above the ground and d is the horizontal distance from where the football was kicked, both in meters. So in this case, I have two letters that are other than x and y, but they still represent x and y, right? So h is the height of the ball, which is, in this case, that's replacing the y, right? And d is the distance from the kicker, so that is my horizontal distance, okay, which represents the x, but I'm using different letters. Doesn't matter, right? Vertical, and is going. What is the vertex of the parabola? First, let's look at this.
8.7.
Just one second. If I look at this, does it look like it's in vertex form? Does it look like vertex form? It does, right? So I have h or y is equal to an a value bracket, an x or d minus value squared plus a value, okay? So that does look like the vertex form, which is y equals a x minus h squared plus k, right? It has the same formula. What can I find from the vertex form? The vertex. What is my vertex?
Is 8.7. 7.6.
Perfect. So the vertex is 8.7, comma 7.6. I write it as a point. All right. So that's the vertex. This is, what does the vertex represent? In this scenario.
Top of the arc or the balance,
Sorry?
top of the arc, the highest point of the ball was kicked.
That's right. The highest ball, the highest point that the ball reached, right? So this point is where I kick the ball, right? It's gonna go up and then it's gonna go back down, right? So that point represents the highest point that ball has reached. Okay? We're gonna talk more about it later. Now, what is the football's initial height? How do I find that?
By the step patterns?
It's gonna be harder to do it with a step pattern.
And I started since it's in English, I guess it's when x equals 0,
Mm-hmm.
so it's 1.
You mean the first
So
kick?
here is d equals 0.
That's right.
Yeah. So I
Okay, so let me
and
plug in 0 for it. That's right. Okay, so let's just think about that scenario for a second. Initial height. So that's the height of the football before I kick. Okay? So the height of the football before it was kicked. Now it could be on the ground, it could be just above the ground, it could be in the air, it could be, I don't know. Okay? So we're gonna have to determine that. How far is the football from the kicker before he kicked it? It's 0, right? They're at the same, because if I'm gonna kick a ball, I should be close to that ball. I should be like at where the ball is, right? And I'm gonna kick it. So that means the horizontal distance from the kicker is 0. Okay? Anytime we're looking at initial, we're looking at the x value to be 0. In this case, my x is d. Okay? So if I'm looking for an initial value, I'm going to have to replace the d, which is the x, to be 0. Okay? So h equal negative 0.1, 0 minus 8.7 squared plus 7.6. So BEDMAS says I have to do my brackets first, then my exponent. So if I do the bracket, that's going to be negative 8.7 squared and then multiply by negative 0.1 and then add 7.6, and that gives me 0.031 meter. How do I know it's meter? Because the distance is the horizontal distance from the football kicked in meters. Okay? So, if you want to write a side note, anytime you're looking for the initial value, is when the independent variable, which is x, is 0. So I plug in 0 for the independent variable. Okay? Remember, in this case, what's replacing x? What letter is replacing x?
The
G. So what's the height of the football? What's the initial height of the football? What do I do? It's a word problem. Always you're going to end a word problem with a therefore statement. Okay? You're going to have to tell me what is the answer. So you're going to say therefore the initial height of the football was 0.031 meter. I'll be looking for the therefore statement, and I'll be looking for the unit. What's wrong?
How did you pick the H? Give me the different result there. It's 8.7, right? 8.7 minus 7. Give me this.
Times negative 0.1.
Um,
No, you have to do multiplication first, then
okay. Like this.
there.
Yeah, I added.
All right, now they want. Okay, now to graph this, what do I know?
The vertex,
I know the vertex. What else do I know?
the initial point.
The initial point, right? So these are 2 points. Because of the symmetry of the quadratic function, I can find a third point, right? So let's first, this graph, just so you know, it's not going to look perfect because the numbers are pretty, 8.7 and 7.6, they're not pretty, okay? So I don't know if you guys can see the little grids. I used 2 small grids to make one, and then 2, 3, 4, and so on. so. So I know that my vertex is at 8.7 and 7.6. So I'm gonna put 8.7, that's about here, and 7.6 is about here. So this is where my vertex is approximately. Then I know my initial point, which is at 0.031. So just so you know, we need to label the axis. So this is going to be the height in meter, and this is going to be the horizontal distance in meter. Okay. My initial point is at 0.031, so that's very, very close to 0. Okay. Now, I have only one part of my quadratic. Okay. I need to find my other part, the other section. So because of this symmetry, I know that I can find a point that's symmetrical to this point on the other side of the graph. Okay? So, if you look here, on the x-axis I have 8.7, right? So if I go 8.7 from the vertex, I'm going to land at the same y value, okay? Because of this symmetry. Okay? So, what's 8.7 plus 8.7? 17.4. So, that's 17. So, it's going to be around here. It's going to be about 17.4 and 0.031, and that would be my second point. Okay? So, let me recap this. Eyes on me. Because of the symmetry, I know that my vertex is in the middle. It's where my axis of symmetry is. So, from this point to the axis of symmetry, I have 8.7. Right? So if I go 8.7 on the other side of the axis, so if I travel 8.7 on the other side of the axis, I'm going to land at the same y value. Okay?
So necessary to replace y equals 0, right?
Sorry?
Here we replace the x equals 0, right? To find the h.
Yes.
So not necessary to replace
No.
y equals 0.
No. It's going to be harder to. No. Yeah. It's not asking you to do that.
Oh, okay. No, I need to find the other points.
No, because then it's going to be like somewhere right here. If y is equal to 0, it's going to give you the two zeros, but you don't need to do that now. Okay? You can just simply find another symmetrical point. Okay? That's enough. You can if you do it, it's not incorrect. Okay? You're going to get 2 extra points. So, what does the vertex represent in terms of the football's path? So if you're looking at the vertex, what does it represent? How can you explain the vertex to me?
That the ball has reached.
So that's the highest value that the ball has reached, and the highest value is at what? The highest point the ball reached is 7.6 meters, right? And when did they reach that point? When did it reach that point? meter from the cable, right? That's your horizontal